Hi, in this experiment we're going to measure the experimental value of the ideal gas constant R, whose theoretical value is 0.08206 liters atmospheres per Kelvin mole. We're going to do this by measuring the volume, pressure, and temperature and number of moles of hydrogen gas, which is generated by the reaction of magnesium ribbon with HCl. We'll collect the hydrogen gas over water, correct for the vapor pressure of water. Using the analytical balance with the door shut, press the tare button. Then weigh a piece of magnesium ribbon. The ribbon should weigh between 0.03 and 0.05 grams. Record the exact mass in your notebook. Carefully wide the magnesium ribbon and then tie it fast with a piece of copper wire. Put a bend in the copper wire about 1 inch away from the magnesium ribbon. Under the fume hood, obtain about 5 milliliters of 9 molar hydrochloric acid. Then place this into your buret. Your buret should now look like this. Next, we're going to fill the buret with room temperature water. Place the stopper in the top of your buret, pinching the copper wire carefully between the outside of the stopper and the wall of the buret. Make sure the magnesium ribbon is about 1 inch inside the top of the buret, and then completely fill the buret and the hole in the stopper with distilled water. After recording the temperature of the room temperature water in your large beaker, which should be about 2/3 full, you're now going to invert the buret, covering the top with your finger and holding it upside down underneath the level of water in the beaker, and only then letting go with your finger. You'll then clamp the buret upside down with the stopper underneath the level of the water in the beaker and wait for the reaction to occur. The HCl, which was formerly near the tip of the buret, is more dense than the water, and you can see that it's slowly starting to work its way down to the bottom where the magnesium ribbon is. Then the reaction is going to start. Once the reaction begins, you'll see the magnesium react with the HCl to make hydrogen gas. The hydrogen gas will then rise in the buret and get trapped at the top. Once the reaction really gets going, it's actually fun to watch the bubbles rise up. The reaction is really going well now. Once the bubbling is done and all the magnesium ribbon is gone, tap the buret to make sure you got all the hydrogen gas that's stuck in the hole in the stopper to rise up to the top. Then you have to record two different things. The first thing you have to record is the actual buret reading. Remembering that we're reading the buret upside down now, the meniscus here is between 14 and 15. It's around 14.9. Record the buret reading. second thing we need to record is delta H. Delta H is the height of the column in the buret relative to the water in the beaker. In this case, it's 15 centimeters from here to here. And then another 3.2 centimeters from the mark that I just mentally recorded to the meniscus and the buret. So a total of 18.2 centimeters or 182 millimeters of water. You're also going to need to record barometric pressure, which here is 29.77 inches of mercury. You'll have to convert inches into millimeters of mercury. Then for whatever temperature you had for your room temperature water bath, you'll have to look up on the internet what the vapor pressure of water was at that exact temperature and record that in units of millimeters of mercury. You'll need these values for your calculations. Repeat this experiment another 2 times for a total of 3 trials. To calculate the pressure of hydrogen, you're going to have to take atmospheric pressure in units of millimeters of mercury and then subtract the vapor pressure of water in units of millimeters of mercury. And then you're going to have to subtract your delta H value in millimeters of water divided by 13.6 to convert it into units of millimeters of mercury. This will then get you the pressure of hydrogen in millimeters of mercury, and then using the conversion at 760 millimeters of mercury is equal to 1 atmosphere, you can convert that pressure into atmospheres. To calculate the number of moles of hydrogen, you're going to assume that all the magnesium wound up as hydrogen gas. There's a 1-to-1 stoichiometry because the balanced equation is magnesium solid plus 2H plus aqueous goes to magnesium 2 plus aqueous plus H2 gas. Thus, you'll take the grams of magnesium divided by the molecular weight of magnesium to find the moles of magnesium. Because the 1-to-1 stoichiometry, this is the same as the number of moles of hydrogen gas. The temperature will be the temperature that you recorded in degrees Celsius of your water in your beaker, assuming that it was at room temperature. The air temperature of the hydrogen will be the same temperature. And you'll convert this into degrees Kelvin by adding 273.15. To measure the volume of hydrogen, this is a little tricky because we know that the hydrogen was occupying all the space from where we recorded our buret reading to the 50 milliliter mark on our buret, plus all the space between the 50 milliliter mark and the tip of our buret. It's easy to calculate the amount that was here because we can take 50 minus our buret reading. But then we have to add to that this amount, which is what we're going to call VCal. So in the second part of the experiment, we're going to fill our buret right to the 50 milliliter mark with distilled water. Next, we're going to tear our analytical balance. And record the mass of our small empty beaker. Then we'll place that same beaker underneath the buret and drain the water from the 50 just down to the top of the stopcock. You don't want to drain it all the way out the tip because there was no hydrogen in the tip, just to the top of the stopcock like that. Okay. And now we'll reweigh this amount of water. Reweighing the water in the small beaker and then subtracting the mass of the empty beaker will get you the mass of the water. Then looking up the density of water at your temperature to at least 4 significant figures, you can then use the density and the mass of water to find the volume that was in the VCal space in units of milliliters. Convert this volume into liters before you calculate R. So now that we have the value of the pressure of hydrogen, the volume of hydrogen, the moles of hydrogen, and the temperature of the hydrogen gas, we can calculate R from the ideal gas law, that R is equal to PV over NT. Do this calculation to the correct number of significant figures for each of the trials, using your average VCal for volume of hydrogen in each trial. Then once you have your average R value, compare that to the literature value of 0.08206 liters atmospheres per Kelvin mole and calculate the percent air. And answer your post-lab questions in your notebook.